I'm going to now look at questions 3 and 4, and this is from your wavelength of light and your Planck's energy equation practice. And these two questions in particular are going to merge the two equations together to help you solve for one unknown variable. So I have question 3 written out for you. I also have your two formulas that you're using and the constants that we're using. So speed of light for this question is going to be 3.00 times 10 to the 8th meters per second. And Planck's constant is going to be 6.63 times 10 to the negative 34th joules seconds. So what we're looking for here is we're trying to calculate the energy of a photon of radiation that has a wavelength of 6.4 times 10 to the negative 7 meters. So the variable that you have right now to work with is this variable right here. You just have wavelength. And you're ultimately trying to solve for your frequency to begin with. Once you now have your frequency, you can go to your next formula, plug that frequency in. Planck's constant is a constant, so you always know that number, and you're going to be left with your energy. So you just have to use these in a multi-step approach. So let's begin. If I have wavelength, that is my only variable that's given to me in the problem. So that's 6.4 times 10 to the negative 7. How do I know it's wavelength? In case they didn't say it in the question, remember it has units of meters. So a distance unit would be a wavelength. So now what I'm going to do is I'm going to first use my speed of light equation. And I'm going to isolate for frequency. So that means that my formula is going to be speed of light divided by wavelength. Speed of light, if you notice, is not mentioned in the question. Planck's constant is not mentioned in the question because these are constants. You always have these variables available. So my speed of light here is just going to be 3.00 times 10 to the 8th. I'm going to write my units like this, meters over seconds. I'm not going to write it with a slanted fraction, so it's easier for me to see what units are canceled. And then I'm going to divide all this by the wavelength provided in the problem, which was 6.4 times 10 to the negative 7 meters. So hopefully now it's easier for you to see meters in the numerator, meters in the denominator. Your remaining unit is seconds. So you have one option here. You could say 1 over s, or you could even say s to negative 1. Remember, this also means hertz. Any one of those technically is okay for us, and especially for this problem, you're going to either stick to this or you're going to stick to that. And so if I go to my calculator and I plug this in, I want to make sure that I leave my calculation answer alone. So in my calculator, I just want to remember to do parentheses anytime that I'm dealing with scientific notation. Otherwise, it's going to do an entirely different calculation for me. So remember to always put in your parentheses before and after the scientific notation. So my calculator says that all of this equals 4.6875 times 10 to the 14th. This is my calculation answer. I'm not doing anything with sig figs yet. That should just be my last step. So this right here is my frequency. This is the frequency that I was able to calculate. So now what I can do for this next part is just go into my energy equation, my Planck's energy equation. And so now my formula for that is going to be E equals Planck's constant times frequency. I have frequency, it's this frequency right here. And now I can just straight times it by Planck's constant and get my energy. So that means my energy equals Planck's constant, which is 6.63 times 10 to the negative 34 joules seconds. And I want to multiply that by my frequency. And remember, I want to multiply with my calculation answer, not a sig fig answer. So 4.6875 times 10 to the 14th, s to the negative 1. And hopefully now you also have a chance to see that s and s to the negative 1, those are reciprocals of each other. Your remaining unit here is joules, and that's your main unit of energy. So if I go to my calculator, I can either plug this in or I can just leave it saved from the last calculation that I did, and I can go ahead and just say times Planck's constant, but you want to remember again to always use your parentheses. So my calculation answer right now is 3.1078125 times 10 to the negative 19th. Now I need to go back and look at sig figs. I only had one piece of data, and that was it. I never look at constants as data. Those are exact numbers, so they're infinitely significant. This was my only data, and my data happened to have 2 sig figs, because remember in scientific notation, you just look at your coefficients. So now if I need to deal with 2 sig figs, that means 1, 2. The 0 does nothing to the 1, so the rest of it just gets kicked out. So here's your final answer. 3.1 times 10 to the negative 19th, and my remaining unit is joules. And that's my final answer for this particular question.